Hello, hello. And we are going to do day 4 of the Advent of Code now. Let's see. And improve the language. Just like all the other days of the Advent of Code. Let's get started. Penguin Operator, welcome. An early Kuviman. That's the normal time that when I should be streaming, I think. Maybe like even a little earlier than that. But yeah. I'll probably be streaming more in like the first 3 days of the Advent of Code, like the late one. Easier to do other things then. Hello, C Program Lover. Yeah, I'm live earlier. Open the cast. Open the Advent of Code. Do you think you need to do some changes for cast because of day 4? I don't know. I did not read the thing yet. We'll see. It depends on the problem that they have, right? Maybe I will need to do something. Maybe we already have everything ready. Let's see. Did you solve the Advent of Code day 4 yet yourself? Yeah, also someone said that, like, I was yesterday wondering if I can actually see the answers, but we actually see the answers here, right? We actually see the answers here, which means that we can actually write tests even, if I want. Yeah, like one of the things that would be really nice if I could test, the old, the previous days that they still work as I like change the language, you know, that they still compile and they still run properly. But yeah, still working. So see you tonight. All right. Let's see. Day 4. You ride the escalator down to the printing department. They're clearly like. Do you guys care about this the lore here? Because I don't even remember the lore anymore. Like I have been reading it, but it like I read it and then I forget about it instantly anyway. Hello, Betsec and Pigorly. Today once again was very easy. Well, I mean, there are like usually in the Advent of Code, the like difficult days start from about around day 10.
Hello, penguin underscore operat 0.
Right? Like relatively relatively difficult parts only start around day 10. Since this year there's only like 12 days. I don't know if they like changed like how like the difficulty, or did they only keep like the early like easier days. But yeah, you can go back and read the lore. Yeah, I don't know, I think I just don't care. Let's just read the actual thing, because I forget about it anyway immediately. Let's see, we have the rolls of papers that are arranged on a large grid. So we have the grid like this. The elves have been even have a helpful diagram indicating where everything is located. For example, this is our example. Let's go ahead. Let's add day 4 like so. No, not move. I wanted to copy. I think this code is lagging or something. Is voice bad or my internet? It is sometimes breaking the microphone. Maybe that was happening again. I don't know. If it doesn't, it's not your internet. Is it fixed or is it still bad? Let me hear it. Let me hear it. Twitch, let me... Oh, not move.
Where are you from, Kubi Man?
I think this code is lagging or something. This code is again, I don't know. If it doesn't, it's not your internet. Is it fixed or is it still? I think this code is lagging or something. Yeah, I guess like the normal compiler's voice, whatever. Where am I from? I'm from Russia. The forklifts can only access the roll of paper if there is a fewer than 4 rolls of paper in the 8 adjacent positions. If you can figure out which rolls of paper the forklifts can access, they will spend less time looking and more time breaking down the wall of the cafeteria. In this example, there are 13 rolls of paper that can be accessed by the forklift, marked by X. Oh, is there like an X somewhere? Wait, no. Oh, yeah, these are marked by X's. Okay. The forklifts can only access a roll of... So the X is the rolls of papers, right? We can access a roll of paper if there are fewer than 4 rolls of paper in 8 adjacent positions. Oh, okay. Yeah, that makes sense. We just, for each roll of paper, calculate the amount of adjacent ones, and if it is less than 4, then we add 1 to the example. Sure. Yeah, that is really easy, indeed. But is it really easy? Let's see. Let's see. Day 4. Day 4. So first of all, we need to read the input, and then we need to read the lines that are not empty, right? So string lines input line if string length line is not 0, then map. Then let's do this. Map is list push back map line. Let's just do something like this. Map is list create, something like that. It's just 10 to the power of 5 array accesses. Yeah. Which means that it's going to be relatively slow here, actually. For me, I guess. Okay, so we have a list of strings. Like so. Then we just do list iterate. Just do for I in 0 to list length map. For j in 0 to list length list at map I, something like that, right? Type check failed. This is not string. Oh yeah, because it's not list. This is like string now. Or you can short circuit before checking all adjacent. Yeah, you can do that too. Also, you can do it without multiplying by 9 by doing the prefix sums, I suppose. So that in that case, you just check, like, you get the amount of paper rolls faster, but I think it's not worth it because still you still need to like take a look at 4 positions in the array instead of 9, which is like not different. And in case of my interpreter is actually going to make it slower. Yeah. Well, I guess you can like move the window and like recalculate the amounts or something, make it more efficient. But yeah, we're just going to do this simple stupid thing, right? So we say that yeah, then we do 4dx in 0 minus 1 2 2 for dy. I guess we call it di and dj then. Yeah, I plus, so that is not I plus dx. I don't know. So adjacent I is I plus di. I mean, we can just say that over here for adjacent in I minus 1 to I plus 2 j plus 2 j minus 1, right? Something like this. Then we say that if, let's say over here, right, that n is this and m is that, something like this, 0 to n, 0 to m. I think that makes sense. And then over here I say that if ai is if this and ai is less than n, and aj is from 0 to m, then we just turn to AI. Can't believe this. Yeah, we have yeah, we use AI to solve this. Okay, so we do that, and then we say that if string at list at map I j ai and aj, right? If this is equal to at, then adjacent papers plus equal 1, right? Over here we say adjacent papers is 0, right? Adjacent papers will also count the paper itself, I guess. If we don't want to count the paper itself, then we also need to say that AI, I guess we say not AI is 0 and AJ is 0. How would we like format this? This is a long if, right? So we don't like this really. This is not very likable. How would we do the formatting here? Or do we use variables to write this code instead? Like, I feel like what I would format it is something like this. I would also put this in parentheses because that means that like AI is in the range and this means AJ in the range, and then I would put then on like this line. Maybe is how I would do that. But my formatter does not do that right now. And yeah, it's like I would need to change the way my formatter works to put then on its own line anyway. Unless I also then put this in parentheses, because then it can do it like so, but then it will still... Yeah, then it could be formatted like so, I guess. So yeah, if we have a multi-line, then we do this. Does that make sense? To format like so. I would yeah, formatting is like important, right? We don't want this long line. I think so. Like if I use the plus here, for example, right, the math operators and minus, this already is going to format this properly, actually. So I need to do the same stuff as I'm doing for pluses and minuses, I think, for ands and ors. It should be easy, I think. Let's open this syntax rules. Yeah, we do either space or we do /n. Basically, that is all. So when we do end, this over here is also either space or /n. Over here and over here, and we do not never, we do if any. That's all. That's literally all. Let's go to hello. So if I say something like this, if A and B and B and C and D, then do something, right? And then we try to format this file. Then it's going to be formatted like this, right? There we go. Unless we put it all on like the same line, then it's going to keep it on the same line. We like keep the formatting, but if we have at least one break, then it's going to put every single thing on its own thing. And if we like make this in parentheses, then it's going to be like that, which is exactly what I want, I guess, right? Okay. Wrapping or and or. Improved formatting for multi-line and update cast. You're also solving the advent of code batsag. What do you use? They removed the the leaderboards, right? So we don't have a global leaderboard now, but we have personal ones. Is there like some leaderboard that we should join? Bad Cops one? Oh, there we go. I'm in the Bad Cops leaderboard, and BadSeg is also here. The language Rust. Let's see. So the leaderboards just tell us which time zone people live in, right? Because how easy the advent of code is. It's like 9 a.m. for me, pretty good time. Yeah, but like it's assuming that that I am waking up at 9 a.m. like a normal person, you know, like a regular person. But no, that's not what I do. 9 a.m. is when I'm sleeping. 10 a.m. is when I'm sleeping. 11 a.m. is when I'm sleeping. All right, so we calculate the adjacent papers. This is the formatting now, which I think looks pretty nice now, right? Like we don't technically need these parentheses, but if I don't put these parentheses, then it's going to be like a little bit weirdly formatted, right? So I actually want this, I think. But should it be formatted like that if I don't have parentheses, then it would be like this. It feels a little bit weird then. I don't know. Yeah, I like parentheses. In this case, I have a long if condition. Alright, so we do this. We calculate the adjacent papers. Also, I only need to do this if this thing itself is a paper, right? So let's actually do this. Let's have a function at is like aij, and then we just return this thing. You know, at I and at j, you know, like this. So if at ij is a paper, right? Because I will also want to do that here. So if at this should be ai and aj, and this should be at ij, this paper, then we do all of these things. I guess if it's not a paper, then we just continue, which is another thing. Another thing that I don't have is continues. I have breaks, but I don't have continues, right? I can do a continue real quick, similarly to the loops, I guess, right? Let's see. Core break. Yeah, we have loop, and then we have break. And then let's also have continue then. And then syntax here. Roboto, hello. So break is desugared into this, unwinding to the current loop block, right? Yeah. And then over here, what I want is basically for the loop, in order to continue, I need to unwind, but continue the loop. So I need to put the body itself into another unwindable block, I guess. Which is going to be comp time win std loop block body, I guess. So we have two blocks like this. We can call that a loop block, and we call this loop body, loop block, loop body. Yeah, are you developing your own language as you do Advent of Code and notice what's missing? Yes. Well, I mean, technically I can solve it without missing these missing parts, but like I'm just making the language nicer as I go, right? Some of the things can be implemented in the language itself. Some of the things actually need to like do more stuff. Like a lot of these things, like breaks, loops, and continues, right? This is just syntax sugar. Like plus equal is syntax sugar, so that's like really easy to do. And then we need to do std loop block, std loop body, right? And then the syntax continue is very similar to break, but we break from the current loop body, not from the entire loop, but only from the current body of the loop, right? Basically, yeah, that makes sense. Okay, and then we have in stdlib, I guess, a loop block. What is this? This does not need to be here. Loop block and loop body. Context unwind unit. Yeah. Yeah, sure. It's a little bit hacky for now, but good enough. So now if I do something like this, let's do this. Let's do this. Cast, right? So I do like for I in 0 to 10. And then I say that if I is less than 5, then continue. Else dbg print I. I think this needs to be in parentheses, right? Like this. Dbg is not found. Let's do std dbg. Beautiful, it doesn't work. What if I do just that? Did I break this? Yeah, no, I did not. If I is less than 5, then nothing else. Print. That works. So it's just like the continue that doesn't work. If I say break here, then it stops immediately. So breaks work. So it's just actually the continue that is actually not working. Oh, I understand the why. I understand why. Because for I in 0 to 10 is also another thing, right? So I'm continuing without... I'm continuing like the loop. You know? Like, here's my for. My for is desugared into a while like this, right? And while is desugared into a loop like this, right? And loop is desugared into this. And so when I continue, in this body, I don't append the plus equal here, right? Which means that, like, in this case specifically, I guess, in this case, we will need to... I will need to do that, I suppose. All roads lead to go to... Yeah. So this is the actual loop body. And then inside of the loop body, we do these things. Right? But yeah, and then if I break out of the loop body, I will still add the loop variable plus equal 1 on the outside, right? Yeah. That makes sense. There we go. Now we actually can continue, right? Continue. Try doing if I is more than 5 break. That's what I added before. I added breaks earlier. If I more than 5, then break. Like, I did that already. Because when I did the break, I forgot that there also is continue that I should think about. Alright, so now we have the continue here. That is easy. And this should work, right? And then we say that basically if adjacent papers is less than 4, then answer plus equal 1. Right, and then we say that answer is 0 and dbg print answer. Okay, so the answer is 4 for the example. No, it's not 4. It's not 4. This is not correct. Okay. Let's see over here, dbg print ij, right? Let's see what are the positions that I found. Uh, 2, 6. This one? This one definitely has less than 4. But what about this one? And that one? 7, 0. Is this one? Maybe I should just print IJ adjacent papers. Let's try this. Right? And let's just check. So for... Well, first of all, I started 0, 2. Okay, I think I see the problem here. I think I maybe see the problem. Oh, wait, no. It's not, no. It's because I'm continuing if I don't see the paper, right? So, like, yeah, that makes sense. Because the first paper is at 0, 2. That makes sense. Okay, so adjacent paper for this one is 4. Do I count the paper itself? If not... Is it because of the priorities here? What if I put this in parentheses? No, it's not. You see the bug? Is it like I and J or something? AI, AJ. You will not tell? Okay, it's some stupid bug, right? At IJ, I think is correct. NM. Incredibly stupid bug, like always. Okay. You would do this bug? AI is from 0 to N, AJ is from 0 to M. At AI AJ is this, then adjacent papers plus equal 1. It's on line 31. If not, AI is equal to 0 and AJ is equal to 0. Oh, yeah, that makes sense. I and J, right? Yeah, it's because like previously I did it for the deltas, but now we actually like do the loop from this, right? Yeah. I guess we can also say something like AI AJ is not equal. Is this actually going to work? I'm not sure. Is it not equal to I and J? Kind of would be nice. But I think this actually does not work currently for tuples, probably. Yeah, probably doesn't. So we will have to do it this way for now. And now we have 13. What happens when you try to access out of bounds in your language? Right now, it's going to do an error. Let me show you cast, and when we do like string, yeah, so we have like hello, and we try to get an index -1, right? It's going to say, well, this is not going to work, right? String is not in scope. It's std string. Yes, it's like it's showing out of bound, interpreter error, yeah, and stuff. Which is, I guess it's going to be like a panic. It's going to be like changed. Eventually, this is going to. I don't know. I don't know, like if I'm going to change the API, right? So in some languages, this returns an option, right? In some languages, this throws an exception or whatever. In some languages, as undefined behavior. What I want is to be able to have all of these like available, but without it being like a different function in some way. So I think it's yeah, in rust.get is option, and this is panic. Yeah. So I want something different. What's the theme you use? I'm using one dark. Like basically, I want to have an effect system, right? So the string at is so, and this function, right? This function can basically do out of bounds. So should add be of type int into not character but a character option. No, the actual type should be that this returns a character, but it also like I don't know, can fail like something, you know, like with potentially out of bounds. Like this is like a checked exception kind of thing, right? And then we would basically use this, and we will need to handle the potentially out of bounds thing. So when I say like at map 00, this is the thing that is actually going to give me the character, right? But there is potentially for out of bounds, so we need to handle it somehow. One way to handle it is to do like try or some other keyword. We'll see about that. And this will actually give me the option, right? If this fails, or a result, right? The result will probably like make more sense for this, and it will be the error variant, which is like out of bound or whatever, right? And another option is like this how Zig does it. Yeah, basically like similarly to how Zig does it, kind of. But also we also should be able to do the undefined behavior too, for performance reasons, right? So we should be able to eliminate the out of bound check, and the try is basically syntax sugar, right? So this should be syntax sugar for handling the effect which is potentially out of bounds, right? So it will be something like this, you know, with like potentially out of bound, and handler for this effect is basically a function that like does something when this is happening, right? So I don't know, like, I mean, so we can just say like unreachable or something, which means undefined behavior by like, and that's how we would do it. And then the compiler would see it and eliminate the bound checking, I guess. I don't know, something. This is like a rough idea for now. I don't know exactly like the syntax and stuff for now. But it should work, and like the same way is going to work also for integer overflows and like other things like allocation failures, right? A lot of these effects should probably like be handled like in main, and it will like just result in panics by default, or maybe you should opt into that default. We'll see. But that's like the general idea, which means that it like all of these things are valid options of how the bounce checking should behave, right? But I want all of these options to still be very ergonomic. So the fact that Rust gets like in Rust you have the safe option with .get and the like the panic inversion with the square brackets, the indexing operator, makes it that the more ergonomic version is the panicking one, which is wrong in my opinion. Does class contain nulls, undefined, or anything of that sort? No, we don't have nulls yet. I mean, I'm not going to. We have ADTs, some types, right? Tagged union stuff. So you do it similarly to Rust, where if you have an optional, then you have like either some value or none. That's how it's written in my language right now, with a colon and then like the variant name. So you explicitly do that. Undefined, when you say undefined, are you saying undefined like in JavaScript, where it doesn't actually have a value? I have something similar to that. I have the special value which a lot of languages don't have, which is uninferred. I can say like this. I can say this, let x be underscore. So what is x? What is actually x? X is just underscore. It's not inferred thing yet. We don't know what it is. But if I say like something like let y be of type x and be equal to 1 to 3, right? Then because I used x in this position and this is an integer, now we know that x is an integer. You know? Like, we have something like this, which is a little bit weird. But I think this also makes a lot of sense. Right? But we will want to have like undefined in terms of uninitialized data, like in C++. When you create a variable, you want to create a variable which does not have a value yet, right? For performance reasons, right? We will want to have like some safety checks, so like so it's more like Rust. Once again, the language more than C++. In like is the idea maybe uninit? Maybe uninit is a little bit too explicit. My plan is to be a little bit different. So in Rust you can write something like let x, and then you say like, let's go to the Rust playground maybe. In Rust you can write something like this, let x, right? And then you just say x is equal to 2. So like before you have assigned, this is not initialized variable, but before it's initialized, you are not allowed to use it, right? Something very similar to that. It's similar to borrow checking, I guess, but it's, I guess, initialization checking or something, right? This can be done inside of an if and stuff. And Rust will check that you only can use your variable after it's initialized. We will want something similar to that. So in this case, you don't really do maybe uninit, right? Because this can be like statically checked. Maybe uninit is more about writing unsafe code when it cannot be determined statically, I suppose, right? So yeah, maybe that will also be needed. But one of the differences that I'm also planning to is that in Rust you cannot have a reference to the variable. In Rust you cannot create a reference to x before you initialize it, and I should be able to do that. I want to be able to create these references because but it also will mean that I cannot dereference this reference until x is initialized, which is going to be like a little different. Is there a dynamic memory allocation yet? Well, right now the language is interpreted. I'm just like I'm talking about the future of the language, right? Right now the language is interpreted. I don't even have the way to do the references yet at all. Maybe I should. If today is like really easy, maybe I will actually work on references and like replace expressions. Because right now, as you can see over here, right, I'm saying that map is a list pushback map. So like I'm creating a new list. And then I'm like reassigning the variable instead of mutating the list in place, which is like bad for performance technically. Do you have EVCXR installed? It's a Rust REPL? No, I have not even heard about this. Nix run, Nix packages, EVCXR. This thing? Let's see. Yeah, let's just download 250 megabytes, sure. Download Rust, and it will compile it then, sure. I'll test it. How do you clear unused memory? What do you mean clear unused memory? Like I said, in the future, it's going to be something similar to Rust and C++, where you have the destructors, the drops working, right? But for now, it's going to be like garbage collected interpreter. How you have a plan for self-referential struct? Yes, that's literally the reason why I want to allow references to the not initialized variables. This is important for self-referential structs. Because you need to be able to create a reference to the thing that is not initialized yet. But you should not be able to dereference that reference, right? Yeah. I do have a plan for that. And also like in Rust you can also not do like recursive closures, for example, because that's like the same stuff. That's also a self-referential thing, I guess, right? Self-referential structs, in general, in place construction, I guess, right, is also something that Rust does not allow. And that's something that I want, and that it means that I will also have another type of a reference, which is an out reference or something, as seen as in some other languages, where it's a reference to an uninitialized variable which we must initialize basically. But that will also require linear types to enforce this statically, that the out reference is actually initialized. That's basically means that it must be used, which means linear types. But so yeah, this is like a little bit far in the future though. I can talk more about this if you want. There is also like the borrow checker is going to be improved from Rust, which is based on the idea of the ghost cell. If you're interested, I suggest you can read about this. So my plan is to make this thing the native language feature, and then combine that with the effect system to like allow more stuff than Rust, while still having the borrow checker. There's pin now in Rust to create self-referential structs, but it's not exposed. Well, I mean, there is no like safe way to do that. Even pins are still unsafe, basically. I mean, if you use like through the standard like macros, then it's like, I guess, safe, but yeah, you know. In order to actually create the self-referential struct, you will have to use the unsafe code. Here's the Evixer, by the way. So what do we do here? Help. Show variable type. So this is literally just Rust REPL. X is 1, 2, 3. Expected semicolon. And then we do type X, similar to the Haskell REPL and stuff. Yeah, that's nice, I guess. Can you do println hello world? Does that actually work? Println hello acts. Yeah, that works. Nice. Is it just like compiling the things from scratch on every line? Or is it actually an interpreter of Rust? Pins are not unsafe. Pins are not unsafe themselves, but constructing self-referential things are unsafe in current Rust. But once you have constructed them, using them is safe, yes. Which is why it's not exposed, right? You can create pins without being self-referential in safe Rust, I guess, with like box pin or the pin macro. Anyway. Hello, Okina. Hello, hello, hello. Here's our day 4. Let's run day 4 on the actual input, which I should download first. Let's see how long this is going to work. It's going to take a while, I think. I think this is going to take a while. Maybe I should... maybe I should, you know, like, dbg print line plus int to string I for now. Yeah, I need to like work on my string interpolation. Input txt. Yeah, this is like relatively slow, right? How many lines of code do we have in this file? 140. I mean, we can wait. AV6er. How do you pronounce this this thing? Evexer. Yeah, 140, yeah. 139. No, it's 140. 139 is if you start counting from zeros. But it's actually 140 by 140, I guess. AVCXR. Evaluation context for Rust. Okay. Okay, that was not that bad. 1457. Let's submit. Part 2. Let me just commit this. Day 2, day 4, part. You always count from 0? Yeah, but like the index, the last index is 139, but the amount of lines is 140, right? Even if you count from 0, you still don't say that if there is one line, there's zero lines, right? All right, let's see. Part 2. Once a roll of paper can be accessed by a forklift, it can be removed. Once a roll of paper is removed, the forklifts might be able to access more rolls of paper, which might also be able to remove. How many total rolls of paper could else remove for repeating the process? Oh no. I mean, it's easy, but oh no. You won't tell me how I should count? All right. I mean, actually, this is pretty easy still, I think. We'll just do it the simple way. We'll have a queue, right? Let's just have a queue. If you don't want to loop, you can do BFS. Yeah, we'll just do BFS basically, and we will start BFS at every single point, right? So we'll have like queue, which is the queue of things that we need to check. Queue create, you know, and then we just say that for I in 0 to n, and for j in 0 to m. We just say that Q is Q push I and J to the Q itself,
Hello,
right?
Nigel Ithro.
Like so. Hello MBDev and hello Nigel. We just do this. Why does it say cannot find Q in scope? Did I not expose it from my prelude? For F's sake, please activate Linux, but I'm broke. How can I do that? If only someone give me money. I do not expose. Let's do this here. Should the queue be in the prelude? I think it's nice to have in the prelude. Or maybe I just import it. Q is not in the prelude for most languages, right? Fine, whatever. Let's just say that use use std collections queue. I'm so poor, so I cannot afford attention. Well, I just paid attention to your chat message. So so yeah, we just create a queue, and I put every position in the queue to check, right? And then we just say that while q count q is not 0, which means that while it's not empty, right? We just say that position to check, which is ij, is q. Because I don't have this thing, we need to have like new q and ij, I guess, is new q is q pop q. Q is new q, I guess, something like that. Type check failed. Does it return the thing as the second? You can use q length to calculate answer. Why do you need q? Rustspec deck is not in the prelude. Python's deck is not in the prelude. Yeah. Maybe we don't add it to the prelude. Why do you need q? Well, for doing the BFS. That's how you do the BFS, right? Basically, when I remove a paper, then I'm going to add all of the surrounding positions to the queue so that I check those positions again, right? That's all. On my side, you actually have lower video qualities available today. Did they change it? I think it's like if it's available for you, then it's going to be available for everyone. So yeah, just Twitch decided that today they give me the the transmuxer transcoders. Yeah, that's nice. So like literally nothing changed though. You did double buffering our input. Oh, double buffering is also works, right? But the queue solution is faster still. Like because potentially with double buffering, you will only be removing. Is that 4 nested loops? Yeah, what's wrong with that? I mean, I'm going to redo that though, I guess. So there's going to be only 3 nested loops. Bazoo TV, hi. Is my language server crashed? Q count? Yeah, it's called Q length, I guess. qpop. Yeah, we do that. So then we say, so if at a ij is not equal to this, then we continue. Then we calculate the adjacent papers. We do this. We do that. Just had two arrays with input data. I was doing adjacent calculation on immutable data. I was modifying at this state and then copy to the immutable one. I understand your solution. It's not a bad one, but like I said, it is it's not very, like, well, I mean, maybe like in this specific case it's fine. But like, let's say that you only could remove the paper if there is like if there is only like one, right? It works for this case because we can remove less than 4. If this number was not 4 but 2, then it will be like quadratic complexity over the amount of papers on the map, right? Which is bad. But in this case, maybe because you remove a lot, it's like still pretty fast. Also, it depends on the input, kind of, even in the other case, so yeah. But yeah, we're going to have a queue. This over here, we calculate the adjacent paper, and then if adjacent paper is less than 4, then we say that I remove this thing. Right, answer 0, like this. So now over here, since I remove it, I need to actually remove it from the map, right? And I need to queue the adjacent positions. And when I'm queuing the adjacent position, I also need to make sure that I'm not checking the position twice. I mean, it doesn't matter because, like, yeah, it doesn't matter because I'm going to remove it anyway. Yeah, so over here, I just remove the paper, which means that I need to change my map, right? So I need to have at, and I need to have the set at. Set at is ij and c, I guess, which is going to be string. I don't have string set at, I guess, right? So this is the current symbol, which I don't care about actually, right? What I care about is string. No, I need to like list set at map at I. We do, and then we do list at I, and then we do string set at this jc. That's what we want. Hello, the official Kermit. Hi. Bruh? What do you mean, bruh? What's wrong? I need to like do actually in-place mutation for this to be better. That's fine though. For now. But I don't have the string set at. Char is not empty or this. My input took 26 iterations and genus took 12. That's why you brought? I see. What do you mean your input took 26 iterations? Well, for the part 2, there is they just repeated the part 1 basically 12 times, I guess. And the other person 26 times. It's because the input is actually different for everyone, right? This inputs that you download is different from different people, so it actually makes sense that the answer is different from different people's, yes. People get a little bit more lucky, I guess. In case your solution is slow, you will need to wait twice. Less. Okay, where is the bug in this code? Maybe there is no bug? There is bug. Let's say over here that string is use std string, and we say that we have a set at is string index and character, which is return a new string, right? So I'm just going to implement this very, very wrongly, which is I'm just going to say substring s 0i plus substring s I plus 1 length s minus I minus 1 plus... Wait, how do I make a string from a single character? I think I have no way of doing this, right? Trying to like be able to construct a character from a thing anyway. So the other way I could do this, if I could use not strings but actually like lists here too, I guess. Yeah, let's do list then. Let's do map pushback map line. That. So we push, we add the characters. So, and then characters is list create, and then we do string iterate, line C chars is list push back chars C, something like that, right? In this case, I will not need to do set at for strings. And we don't do string at, we still do list at. And then we can do list set at. Type check, error failed. What is the type checking error here? This should return a character. Oh wait, this is not returning a character, that's right, because this returns the list back, right? Yeah. We just let the inference do the job. Set at just returns the list back. I want to add the named type so that I don't see this, but actually just see a list of strings. Wait, why is it still a list of strings? It should not be strings. A list of lists. Because these are here, list length. 13. Okay, there we go. This still works. Okay, so yeah, now we say we have set at now, right? So we say set at I j just a dot or whatever, all right? A removed thing. It doesn't matter what I set it to. Type check failed. Okay, just the LSP is slow. Wait, set should not return this. No. This should just say, this should return nothing. So it should be saying map is equal to this and semicolon. Yeah, this just returns unit. This is me modifying my map. So we just set that here, and then I need to add it to the queue, the surrounding things, right? Yeah, we just say over here, like so. Again, we go for all of the surrounding things, and then we say queue is queue push queue AIHA, like so. Let's say and in bounds AIAJ. Let's say over here in bounds is IJ, and then we return this. Right? So I also add to the queue if in bounds AI AJ, right? Okay. So it is saying 43. It is 43. There we go. For the example, and then let me like just add something. What was the answer for you, by the way? Because like I should maybe like I should say like over here that I like dbg print removed at to string I plus to string j, something like this, right? Not even dbg, just print. So if I do this on input, and by the way, I should do this only like this should only happen for part 2. If we are in part 2, then we are removing. Otherwise, we're solving the part 1, right? And so this is just 13. Part 2 is 43. There you go. And we do part 2 input txt. Okay, and then we wait for this program to run, because the interpreter is slow. Line 5, line 6, line 7, line 8, line 9, line 10, 11. I also think that maybe right now it's really slow. I think I have a problem with my queue. My queue right now is not linear. It is not like constant time operations for pops and pushes, because it's implemented under the hood using the trips. And I think in the trips also, if I look at the standard library, trip, like I'm using the priorities which are which with the maximum number of 100, which is not good RNG, I think. I mean, maybe it's good enough, but yeah, I should make this number bigger. I should just have any integer random. But this should improve performance if I just do that. Yes. yeah, since like this is just going to be solved, let's work on mutability. Mutability will allow me to, like, I mean, proper mutability with references. That will allow me to do things a lot better. And a lot cleaner, I guess. I don't like how this looks. Right? When I set et and it returns a new list. I mean, that's how you do it in functional languages, but I don't like that. Okay, it's half done. So yeah, let's do this. I will be introducing place expressions, references, references. I mean, that's all. Place expressions and references. That's all. Groovy, man. Val, duck. Hello? You might try to solve these puzzles using XSLT. What is XSLT? Extensible stylesheet language transformation, like the Excel stuff? Or what is it? XML? Extensible stylesheet language transformations? So you are also one of those masochist people. Alright. Good luck. Batchcop didn't know what it is either, because I mean, I don't know. Anyone else in chat knew what this is? It's XML-based language used in conjunction with specialized processing software for the transformation of the XML documents. I mean, do you even work with XML documents? Or you do that for, like, I mean, maybe it works for HTMLs too or something. I used to be an expert in XSLT 20 years ago. Like CSS thing for XML. It can do much more. It can even output PDF files, but it's very over-engineered by the 90s Microsoft. Make your RSS feed just the same as your blog. Yeah. Oh, we are going on the second pass now. I mean, it's not like literally the second pass, but we have like removed the first thing and then we like go over the queue. It would be nice like to know how many things are still in the queue here, I think. But yeah. I also worked on a project which outputted everything from database into XML file, and that file was transferred to different formats using XSLT. Yeah, well, I mean, technically I do work with XMLs a little bit at work, but yeah, we just use Java to process that. Okay, so far this is the slowest running solution. Maybe I should have improved it. I don't know. Maybe I should made it like, I mean, this is the fast solution. It's just the interpreter is slow, and I mean, I guess it's like my queue is slow, right? Yeah, I think my queue is slow is the main thing. Professional Java developer. What does the word professional mean? It means that it's the profession, right? Which means that I'm making money with it. Well, I mean, yes, I guess. But yeah, I guess I'm a professional. Boom, 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 boom. Wait, you said that there's like 12 passes. Is this going to be another pass for me right now? Hold on, this is like the second pass currently. Right? Is what it looks like. It goes like sometimes back to the previous lines though. Yo, Liquid Cake. Hello. Liquid Cake. 1. Thank you for the raid. Hi. How was your stream? Doing advent of code in Owl Lisp. What is Owl Lisp? Hello. I wrote a Mount Sweeper once. Do you think I can use its filling algorithm for this? Okay, now it's working faster. I spent 5 hours doing the problem in Owl Lisp. What is Owl Lisp? Let's take a look. Yeah, I'm doing my own language. Right now I have performance issues a little bit, but like the solution should work. We're just waiting for it to run. Owl Lisp. Let's take a look. Owl Lisp. Is this the thing? On the GitLab, Owl Lisp. 0.2 simple programming language. Code Google.com archive. Purely functional dialect of scheme. Nice. So it's like, and it's also lazy? Like Haskell? Does it have monads? Subjectively pleasant dialect of Lisp. Wait, they have vectors. One-dimensional, indexable, having ON log 256. And wait, what? N log of 256. Access. Like it stores it in chunks of 256 elements, which is why it's the logarithm of 256. It's just branching is, yeah, that makes sense, I guess. All right. So it makes it like still a pure data structure, right? Immutable, right? But it still is effectively O1. Why don't more languages do that? Actually, sounds like is that like is there like a big constant here? $256 array trees. Big array trees aren't uncommon. Are they not uncommon? Well, I mean, usually when you see a programming language and like you see, I mean, I don't know, maybe like I don't really like use these functional languages a lot, right? But normally like they are binary trees under the hood, and like I'm making my own language. I'm using a binary tree under the hood. I'm using, so I have like lists, but my lists are right now trips under the hood. I'm using a randomized trips to implement my lists. which is like which makes every operation logarithmic, but it's also probabilistic algorithm. For persistent data structure, it's still log n because the trees can grow quickly too. Scala and Clojure do use something like this. Yeah. All right. I was just wondering if this is like a pure stuff. Continuation passing style. Like when you say pure, does mean that does have side effects. So how do you print system interface? Where's the print? Where's the hello world? Where's the hello world? Print. This is the effectful. So it's not like really pure, right? In that sense, is what it seems. Right? It does not. Or I mean, it depends what print returns, I suppose. So lambda args, this is the arguments of your program, and you return printing. Maybe like print is the function that returns the monad, right? The IO stuff or whatever. It's almost pure? Okay. It has no monads? Alright. You're in the sense of immutability rather than no side effects, I think. Okay. Alright. But I actually do want mutability. Here's my answer though. Let me check really quickly that my Advent of Code solution is correct. And it is correct, right? So I solved day 4. It's just a little bit slow, even though it's not the problem of the algorithm, it's the problem of my language right now. So what I want is I want to actually have mutable language. I do want like purity in sense of immutability while also having the mutability similar to Haskell. Like it still has the option to do the like st monad, for example, right? And like in Rust, you like I mean, it's not like really purity there, right? But like you have the borrow checker, which is very similar to the Haskell's st monad. So like something that like we want to have like checked mutation, but that's the but that's for the future. For now, we just do it normally, like all the other languages where we just have things mutable, you know. But we will add checking of that through the effect system later. But I need to introduce basically the place expressions and the reference types, right? Basically pointers or whatever. Let's get to it. Part 2. This is the same language you were Advent of Coding last year, right? Yes, but it has been rewritten twice since then. I also have the LSP this time, right? Last time I did not have the language server. So it's a lot more pleasant to write. Like I see I have like syntax highlighting, like all the editor support. It's a little like there are issues, but it's a lot like nicer to write it than 1 year ago. But it's not like really mature because it's rewrite number 3. So this specific rewrite is like just a couple months old. It's not a year old. So yeah, I was still implementing basic features while solving. Every rewrite is a better version. Yeah. Has everyone been doing nested for loops? What do you do if not nested for loops? Well, I mean, I can rewrite this loop, like if you do it in another language, like you can, like, you know, for like AI AJ, like in like adjacent cells of I and j, for example, right? So this is like, instead of 2 nested loops, it's going to be like 1 loop, but this is just going to have the loop inside of this function or something, you know? Or what do you mean exactly, like, without nested loops? Like, in order to just iterate over the 2-dimensional array, right, which is like the 2-dimensional map that you're given in this thing, you need to have 2-dimensional loop, right? I mean, instead of loops, you can do recursion, but in like a function language, which is essentially a loop anyway, right? But recursion is still a loop. Like, it's just pretending to not be a loop. Someone did this with an FFT. The Fourier transform. I convert the input to the char and then calculate the adjacent plus 1 by the line length. Plus minus 1, 0, etc. Hello, I'm soft. All right. Anyway, let me work on the language a little bit. So yes, we want place expressions. What is a place expression, right? It is if you are familiar with the language like Rust, you should know what it is. And in C++, place expressions are L values, while like there are also, so like yeah, expressions, they are of 2 kinds. There are L values or R values. Basically, that's it. Basically, evaluating a place expression doesn't necessarily mean that we need the value of the expression, right? But we just need to know potentially just the place where the value lives, and then we can construct a reference to that. So in order to construct a reference to variable x, we don't need to know the value of x, right? We only need to know where x lives, which means that this x in this place is the place expression. And when you, like, for example, assign like x is equal to 5, and like you have a mutable variable x like this, right? This over here on the left is also the place expression, because you don't need to know the value of x in order to assign to it. You just need to know where to put this value. So we need to know the place, which is why it's called a place expression. That's what we're going to be doing. Last event of code was in Rust rewrite, so it's only been Rust 1 rewrite since. Wait, really? I thought last advent of code was also in the OCaml, was it not? Did I not start the Rust rewrite like after the advent of code immediately or something like that? I don't remember. Okay. Yeah, so it was like a very early in the Rust rewrite then, right? Okay. All right, so here's what we're going to do. We have the here's my types, right? So right now we have the language which has expressions. We have assignee expressions, we have type expressions, and we have patterns, right? That's what my language consists of. And now we will have a new type of thing, which is called a place expression. Right? And place expression is going to be something similar. We'll have some data, and we have shape, which is a place expression shape. So like, what can this be? There are commits on all the trees right in December 2024. Okay. And place expression shape is, so we basically need to move some things from the expression into the place expression. For example, when we are referencing a variable, which is the binding expression, we are actually, this is actually the place expression, right? Because referencing a variable gives me the place where the variable lives, and then we will need to, in order to get the value, we will need to read the value from the place. We have a place expression binding. Let's just start with that, I suppose. What else? Also, like object field expression is also the place expression. What else? Current context should be a place expression. Quote ast match if. Module native type assignment instantiating apply variant tuple generic. I think that's all. Is this all of the place expressions? Field and binding? Maybe. But so in order to have the actual expression, which is getting the value of the place, we will have a new type of expression, which is read place. So we have the place expression inside, and then we read the value out of it. We will also need to have references, right? So I will also have expression reference. So yeah, basically we can do two things with a place. We can either convert the place expression to a reference, or we can convert it to the actual value. Right? That's the two things that we can do. And then also a place expression is a thing which potentially is a temporary variable. So we need to have a place expression temporary of expression. So we calculate an expression, we get a temporary variable, we put it into a temporary place. Yeah. That's it. So now assign the expression can be more general. So we can assign into a place, right? So we can have the place expression here instead of a binding. So let is introducing a pattern which will introduce new places, or we can use existing places to do the assignment. And now I need to copy paste, right? Anything else? I guess I can take a look at what I had previously. Let's take a look. GitHub cast, old Rust version. Because I had these implemented earlier in the old rewrite. Let's see what other things did we have. So place expression is either, we have field access, temporary, and dereferencing. Dereferencing a reference. That makes sense. We need to be able to reference the variables, and we need to be able to dereference them. So place expression, deref, a reference. Reference is just an expression. What about the other things? Let's see, what do we had in the assignee? I just had the tuple, which I will add later. Read place type AST tuple instantiate template function scope call macro call let native string number, then if recursive. I think that's all. So now, let's see. Let me copy this up to expressions and copy that over here. Okay. All right. So now when I'm printing, let's fix. Hello. There's going to be like a long refactor actually. What's going on? Hello, Tapco. I am improving the language. I'm working on my own language, which I was using to solve the advent of code. Day 4 is already solved. So I'm just going to improve it by introducing. You can see what I'm working on over here. I'm introducing place expressions and references, which will allow me to have more efficiency by having in-place mutation, I guess. Instead of working just with immutable data structures. Okay, so we have expression ref expression read place print expression shape. What kind of language looks like functional? This language that I'm writing here, this is not my language. This over here is OCaml, which is what I use to write my language. This one, I guess, is like considered functional, I guess. Although, to be honest, I don't really understand what a functional language means anymore. Like, what's the distinction between a functional and a non-functional language? Because most of the languages these days, they are like allowing you to write in any paradigm, and even like a language like Haskell allows you to write code in imperative style. When you are writing your code inside of a do notation, you're basically writing imperative code. So like, I don't know, what even is functional programming language? What's the definition? Because normally the definition given is that you treat functions as first-class objects or whatever, as first-class values, but that's true for any language these days. Almost. Print, place, expression. Bum, 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 bum. Pure functional, no mutable state or side effects, Haskell. But even Haskell has side effects. It's just your side effects are encoded, right, in the monad. It doesn't mean that you don't have the side effects. You still have the effects. They are just in the type system, which is what I also plan to do for my language, but it's not going to look like Haskell because I'm going to have the effect system instead of the monad system. Functional language just means it's going to be slower than imperative language. Controlled effects rather than pervasive effects. Yes. So like, yeah. So in Haskell, you control the effects by constructing monads and then do stuff like that, right? But yeah, the effect system that I'm going for is a little bit differently, but the idea is still the same. But it doesn't mean that, like, it doesn't make the language functional, though, I think. If you have controlled effects. Because, like, once again, I'm still going to have loops, I'm going to have breaks, I'm going to have returns from functions, right? And, like, all of these things, I'm going to have mutability. Mutability is just another effect. In Haskell, you have, like, stmonad, right, which allows you to have mutation, or you have, like, state monad, which allows you to have mutation, right? So, like, it's just, like, you know, Rust is not a functional language, but definitely a function flavor. Yeah, but like, yeah, I'm just. What's the difference? Well, like, what's the difference between Rust and OCaml then? Like, OCaml is considered a functional language, right? But in OCaml, you do have like mutation and stuff, right? You have uncontrolled effects in OCaml. So why is OCaml even considered a functional language? OCaml has side effects. Why is it functional? And why and Rust is not functional? Like, what's the difference? I do see the term functional as a sliding scale. Does OCaml has mutable variables? OCaml has something similar, like, so in OCaml, the effects there are unchecked, right? In OCaml, you have a mutable variable by constructing a thing that is called a reference, right? So you can, it's like a cell in Rust, right? In Rust, like you have a ref cell. Ref cell, you can mutate it even while having just immutable reference to it. So you have the same stuff in OCaml, right? You have x is reference to 0, and then you can mutate it by saying that x is now equal to 1, right? So that's how you mutate stuff. In Rust, it's in not in Rust. In Haskell, it's the same thing. In Haskell, you say something like I don't remember the thing, right? But you have strefs, or I don't know, you have iorefs too, right? Which is basically allowing you to do the same thing. But in Haskell, this mutation is controlled through the monad system, right? And I am planning for my language to control it through the effect system. And in OCaml, in Rust, it is just not controlled at all, right? But mutation is just another effect. That's what I'm saying. So, yes, OCaml has mutation. And, like, I don't know, F# is considered a functional language, right? But you can interop with, like do stuff, you know. You were aware of this ref thing in OCaml? You know it had effects? Yeah. Yeah. So like there are like just general side effects, like printing is also completely unchecked, and mutation is like also present. So yeah. So why is OCaml considered functional and Rust not then? What's the distinction? The distinction for me is that OCaml is a little bit more annoying to write. Maybe that's what a functional language is. Something that's annoying. Hello, Nerdzel. Can you compose functions in Rust? Yes. You can, of course. Like you do like all the I mean, Rust can also be annoying sometimes because of like the other things, but I don't know. I don't know. Don't forget about the annoying part. On my sliding scale, Rust is closer to C++, but emphasizes the sum types, de-emphasizes the class-based object-oriented programming. Like, it's just like you are comparing Rust more to C++, and to me, Rust is like something that is closer to Haskell, basically, because more things are enforced in the type system than in C++. So, like, the fact that Rust can do low-level stuff is, like, not really important to me. To me, the important stuff is the high-level parts of Rust, which is the, you know, like the type system of Rust is more strict than the ones of OCaml. Kind of. Because of the borrow checker, for example, right? Why is IO safe in Rust? It can't result in undefined behavior. Allows you to introduce common vulnerabilities into Rust program in a memory safe manner. Blazing fast memory vulnerabilities. Are they writing to like the process memory using the IO or something? I saw this trick. Safe implementations of the transmute. That's probably what it is, right? Let's take a look. Source. Transmute. Safe transmute. Oh, it's doing some dummy enums. Lifetime expansion. It's usually like just bugs in the type system or something. That's a different implementation of the same safe transmute than I've seen before. There's like lifetime expansion. Expand. Expands the domain of A to B. Safety, what is that? So this over here is the bug, right? I would probably prefer enjoy OCaml, but I prefer the NoGC languages. Yeah. I don't really care about the GC, but I see the NoGC part of Rust as a side effect for me, right? I just like Rust as a language. It allows me to do the RIE pattern in general is like a good thing, right? And it is sometimes difficult to do in OCaml to like because you still need to manage your resources sometimes. Garbage collector is not enough for all the things. You know. Anyway, let me just work on the language a little bit. But yeah, in general, I'm writing OCaml here, but I like Rust more. For anyone who's wondering. Okay, we have place expression. This one, totally safe. Yeah, I think I've seen this one, totally safe transmute, which is using the IO to the proc self memory. Yes, that's how you do, because IO is technically safe. You can mutate the memory. It actually is unsafe. Yeah, I've seen that before. But it basically means that none of the languages are safe, right? You can write to that file, to that pseudo file in any language, right? So it means that there are no safe languages, literally, right? Every language is unsafe. Because, I mean, unless your language does not allow the writing to memory, the writing to files, right? Haskell is explicitly marking IO has 7 side effects because of this. I don't think it's because of that specifically, but yeah. All right, let's see. We have place expressions. We have deref and temp. We have place expression deref, deref expression. Then we just say deref. Expression. Well, I guess we can call this like reference or something. Because that's what we're referencing. The reference is this. Is that how I do it? Print expression ref. I have 2 ways to print expression. With spans, which means that this needs to print place expression shape. Print expression with types. Print expression shape with this. Yeah. I need to like have the function. How do we print expression? Which is formatter expression unit, right? Oh, and this is without the spans, right? Yeah, no. No. With spans, with types. I think like it's side effects which are not functional. Yeah. Yeah, I guess like that's the like. So yeah, the definition of the functional language is like the functions from math, where like it must be just a function, right? Which always produces the same result or the same argument, right? And as soon as your language has effects, it's no longer a functional language, even if the effect is present in the type system. It's like basically if the functions in my language are not really functions in mathematical sense, I guess, right? And have only one argument. Is having one argument like the important thing for math? In math, maybe. I mean, for me, my functions also have only one argument, but I don't know. Yeah, I think math functions can have any argument of arguments. I think one argument is just for the simplicity of the implementation of the language, which is also what I'm doing here. It is important for lambda calculus. Yeah, I guess. All right, I'm just trying to print the things here. Print expression. This is how I print expression, but this should be like different then, right? So yeah, what I want is like over here, print expression shape. This gives me the way to how do I print an expression, right? But what I want instead is I want to have like the print expression like let me just have a type here or something. Type like options, I guess, of printing is going to be so like right now I either want to print with types or with spans. Maybe like I want both of these sometimes. Maybe you know, types boolean, spans a boolean, right? And maybe sometimes we want like neither. Let's just do that. So it means that print expression should be should have the options of printing, right? So they should be like options, and then print expression. I'm going to give it the options. This is like a named argument. Let's do that. Print expression with options. How about that? Maybe. Carrying partial function application. That stuff is neat. But I know why they resisted calls for it in Rust. It looks so confusing initially to a C++ mind. Yeah, I think I will not do the like. I don't want to encourage carrying and functional and partial function application in my language either. I think it like it's a nice trick, but it leads to like bad error messages also sometimes, and like I don't really see the big benefit of it. Like if you want like most of the times you actually want to apply your function fully, I think. I mean, for example, in this case, right, I'm printing, right? So technically over here printing, I am applying the function partially, right? To construct a function that actually can print the thing that I'm trying to print. But the reason that I need to do that is because OCaml doesn't have a trade system. And yeah, like because of that, I'm like, I don't know. I think in general, I don't really like carrying. It makes a lot of sense for methy and manipulation functions, probably things like sorts, etc., but makes less sense for systems language. But even for a sort, how does it make sense for a sort? Like, let's see. So you say that sort is a function, like, because sort is a function that has like the type, I don't know, for all keys, right? It's like you need to give it the comparator, right? So like ordering or something. Let's do it a little bit more explicit than some other languages. And then you have like a list of A's, and yeah, and then it gives you the new list or something, right? So you do like sort ints is like basically sort using compare int, right? For example, so that's why you do the partial application. But I think that yes, or item score, that would be like based on a key, but yeah. So yeah, let's have like an example in Rust, for example, right? Let's go to Rust actually, because Rust doesn't have carrying. So we have let mutable like Well, I mean, but in Rust we sort like in place. So we say that this is like vec 1, 2, 3, right? And we say a dot sort by key, you know, x times squared, for example, right? Sort by x, sort get coord, yes. I think true functional is about hierarchy types. Does OCaml have that? OCaml doesn't really have that. OCaml has functors, which is a little weird. But I guess it kind of like replaces the higher kind of types. But it's like they have like 2 type systems, I guess. The types and then like the module types. So like because of that, right? Like you still apply your function fully, right? But I mean, I guess you want to have a yeah, I mean, like, let's say, how do you write a function, right? Sort by square, right? This is going to be like a into like a sort by key x x times x, right? So like what you so because of carrying, we remove this repetition of the variable a, right? Basically, and we just say sort by key, right? Something like that. By applying this partially, not giving it like the first argument, which in this case is the method receiver or whatever. But I don't know, like you still want this to be like, I don't know. I don't know. There's also like if you don't want that repetition to be there, there are solutions like in Kotlin, for example, where this is basically like a function which has an implicit argument called it, you know, and you say like it dot. So like it is basically the implicit argument of your current function that you are specifying. I don't know. I feel like yeah. So yeah, like right now I'm designing my functions as taking like all of the arguments as a single tuple instead of making it a function to be returning a function like you do normally in functional programming languages. Syntax affects practicality of an idea. Syntax does have bias in a direction. Yeah. Maybe it's just about the syntax. Technically, I mean, technically carrying is also just about the syntax, I guess, right? But like, for example, I forget this semicolon like over here, right? And now it thinks that this over here is a function that I'm trying to apply to this like thing. That happens all the time. And it's like gives you annoying error messages or something in like OCaml, for example. Not sure how common is that in other languages. Like sometimes you partially apply the functions, which leads to bad error messages. That's my point, basically. For why I don't like it. Because you on accident forget to apply your function, like, you know. This pattern analysis is not exhaustive. Expression ref expression read place. Okay, print expression. Let's see. Print expression with types and with spans. So like I don't want this, right? I want instead have print expression to be the thing that takes options. Like so, options. So then I will print expression shape using options like that. And with spans is this, right? So so this over here, this is me printing the type, and this is me printing the span, right? So I think what we do is we yeah, I just print. Yeah, I just start by printing expression shape options fmt shape, right? Then I say that if options dot spans, then I'm going to print a space and then I'm going to print this without the expression shape, right? I'm going to print the span then. And if options types, then we print this. I need space here. So then I need to print the type. There we go. The objections in the C++ community to UFCS. Yeah. Yeah. What's different from add xy is x plus y. And this. Never mind, ignore that. Act like it doesn't exist. All right. Yeah. I want to make some progress. So maybe I should focus. Print expression shape. Print expression with spans. Print expression with spans. Let's not do that. Print expression with spans. Print target dependent branch. Print expression. Print expression options. Right? Condition. Expression options body. Okay, that one is fixed. Print expression with span. So like, yeah, I remove this function altogether. We just have the single one called print expression now. Over here, I use the print expression. So yeah, we just say inside of this function that print expression. I'm just going to say over here that let print expression be print expression options, and that, right? There we go. Now what? Yeah, these underscores need to be fixed. Let's just do that immediately. Read place. Place. So I print read place. And place is this. Like so, we print place expression with options place, like so. Yes, and then reference is going to be similar. This is just reference. Okay, nice. Print expression pattern match branch. Options, print expression, implement add my int for my int. My output is my int. Good reasons Rust likes this structure, but it's nightmare for currying, etc. Self is special. I don't know, like, how is that different from type classes? Like, Rust traits is literally just type classes in Haskell. So you can do the same in Haskell, right? And Haskell has currying. So the only like problem is self being special, but self being special because Rust has methods and Haskell only has functions. But the difference is just syntactical, right? Haskell's type class is slightly easier to think of the parameters on the same footing. There's no self. Well, I mean, if you implement the type class for the type, then that type is basically the self. But I guess you don't really think about it that way. Maybe in Haskell. Unbound value. Yeah, I need to like create the function print. And print place expression is going to be options into formatter place expression. So function options fmt shape data. I'm predicting that my language, if it ever comes out, will do traits type classes better than Rust Haskell. Nice. Wait, are you actually making a language? Well, I mean, I planned for my type classes and stuff to be also... I mean, I don't know if it's going to be better than Haskell's. I mean, there are some advantages to the way Rust does things, I think. But also, like for example, in that previous example, right? You have implement add my int for my int, and then the output is my int, right? So the output in that thing is the associated type for the trait. I'm not sure if you have that in Haskell, right? So which basically allows you to have like type functions, right? How do you do that in Haskell? There is an extension for that. Okay. Yeah. So you can have a associated type in a type class. Right. Nice. Yeah. So there. Yeah. But what do you mean by better then? Like, what are you going to do better? Any examples? I mean, the way I'm going to do it, the only difference for my language is that I'm going to treat the type class implementation, like the trait implementation, the type class instance as a value. That's like the only difference that I'm going to do, because I want everything to be a value. I think print expression. This should be like print data options data. This over here. Yeah, makes sense. That print data. FMT data is this. Options FMT data. Yes. Data is data, like so. Must be here. Sharing is yoinking. I was typing an example, but now you scared me. Print target dependent branch with options. Print data, options, data. What's wrong here? FMT. Okay, nice. So when I print the place expression, it's going to be similar to printing the expression itself. I'm printing the place expression shape, and then I'm printing the data. There you go. Okay, so this one is going to also be options. Function options. This print expression. Say that expression options. Okay, now I just need the which measures the formatter. Yeah, because this is no longer necessary. Okay, and then we need to replace expression temp. Expression. So this is going to be temporary expression. Like this. Ability to string a to string let int printer to string int. Is this simple? So you stole my idea, I see. So sharing is yoinking after all. You just what? Well, that's what I said, right? Did you see the like I had this already before in my previous implementation, right? Let me open the previous version of my language, right? Let's just do this. I mean, we do nix run cast language old Rust version, right? We do this thing. Or do I not do this thing? No, maybe not. Temp cast, right? We do this cargo run. Why is it not compiled yet? So yeah, here we go, right? We say like, for example, yeah, and also like the as expression is the casting expression where I can cast the thing into the trait. So for example, int32 is a type, right? And then parse, I guess it's std parse, right? Std parse is a template. Std parse, I mean, yeah, I was not printing the things, but this is basically a trait, right? So std parse int32, for example, is a type which is parsing the integer, right? So this is the type which is implementation of parsing for the integer, right? And then we say something like int32 as parse. This is going to give me the value, which is the actual implementation of int32 as parse, right? So this can be like converted into the variable, right? int32 parser, right? Is this, and then we can do int32 parser dot parse 1 2 3, and that's going to give me the 1 2 3, right? That's literally the same thing. That's that you said, right? You did it for the printer. Yeah, it is the same thing. So you literally just stole my idea. Okay. I think it's like even like one of the other things that maybe you should also think about then, if you have the same idea, is how do you do this for, like, for example, addition, right? So Rust is implementing the add trait for the left hand side, right? What I want to do instead is I want to implement the add std. Is it add? No, let's see, what do we have here? I don't remember how I did it before. Like what is 2 plus 2, for example, right? That's the question. It's like this is still syntax sugar. Maybe open NeoVim here so that I can remind myself how it worked. Or maybe like I just open the standard library, standard syntax. Plus unary plus left hand side, right hand side. Standard library, I guess. Plus native plus operator binary plus. Implement. Yeah, we had like copy. Yeah, I also had like the copy trait already, right? Bars. I guess I did not have the it done yet, but the idea is that how do you implement the mathematic like the addition, for example, right? So the idea is that you will do something like int32. So you don't do int32 as add, basically, right? Because you add two types together, so it would be like something like this: int32 and int32 as add, right? Which is in Haskell you have a multi-parameter type classes, I think it's called, right? So, and this is basically like it's like naturally appearing that I can do that in my language, because this is just so add is basically just a template, which is basically like a function from the types into like the type, right? And in this case, it's just a function that takes two arguments. It's like natural. I don't know how to explain this properly right now. But yeah, you basically say that like int32 and int32 adder is this, right? That's how you would write it. So you can have the function that adds these things together, I guess, by doing this, right? And then you implement this as like some concrete implementation. But this was, I guess, not implemented, at least not in the standard library previously. Okay, does that make sense? You know? Yes, yes. Just multi-parameter type classes. I'm just saying that it's not a special feature for me. List print, print expression match branch, options. All right, I'm just now passing the options everywhere. Okay, a binding is no longer an assignee, but we should have an assigning to a place. So we say place. Let's just say place, and over here we just print the place expression itself. No, let's just say play. Yeah, let's just say place here, and then place is this. So print place expression, place options. So options, options. Place print. Print assign expression shape. Print assign expression, not with spans, just this. Give it options. I'm trying to implement the place expressions and I'm just stuck in writing the the print, but it's because we are being distracted all the time. It's fine. Expression shape, options, shape, print data, options, FMT, data. Like this. Print type, expression shape also should have options. Print expression, print type expression, options, print type expression, options. Not compiled yet. So yeah, I don't do the add here, just print type expression. Options, fmt shape. And over here we have not compiled at. And then after this, we say print data options fmt data. Right? Like so. Print type expression shape. Alright, print type expression, options. Just a couple more errors. With a Siny expression, options, print type expression, options. And then over here in the bottom, print expression with spans is print expression, options, spans is true, types is false. Right? This over here, print expression with types, print expression, spans is false, types is true. Print expression shape. We only had the spans there, right? So yeah, print expression shape. Options, and is true, types is false. Let options be this. Yeah, don't do that. Just this. Print expression shape, print expression. Wait, is this even being used? I think this should be removed. I'll do that as a type ability. Add output AB1, where 1 is kind, and ability. Add AB. Oh, you just have type abilities and abilities separated? Okay. I don't see a reason to separate them, but okay. Number 4 kind is not correct, I guess. Or just have it like Haskell ***. Yeah. You're not planning for types as values like cast? Yeah. I see. How far are you making your language? Did you start even yet? Print assign expression shape. Like, is this even being used? Let me just remove this. I feel like I'm not sure if this is being used right now. I'll just say print assigning expression. Option. Print assigning expression. Options. Spans is true, types is false. Type expression. I feel like this is mostly what I want. Print type, expression shape. I feel that's not needed. Print pattern with spans. Wait. And print pattern is the pattern without the spans? I see. Types as values, cast has dependent types, or is dependent types values as types? Cast does not have dependent types yet. I think I need some more work to make it, but I will look into it. I will want to add them, I think, yes. But and to figure out what exactly needs to happen for that. But I mean, yeah, we can treat values as, I mean, dependent types is not just values as types. I think for like proper dependent types, your type can also be like an expression. I think, right? So like, for example, if you yeah, I also didn't do more than 3 lines, so I like, but as far as I understand, right, so what you would use the dependent types for is like the lists of fixed sizes, right? So when you say like the function concatenate to lists, right? This should have you know, like a list of size A and a list of size B, and it should return a list of size A plus B, right? But this A and B, so in Rust you can do that, but in Rust this must be a compile time known constant, right? In order for this to be proper dependent types, you need this to also be like proper arguments, right? So you say like A is of A is just the argument, you know, a named argument of like int, for example, right? And B is int, and then the type of the second argument is depending on the value of the first argument, basically, right? So this value, like the concrete size of this list, is only known at runtime, right? So that's how you, that is proper dependent types. Yeah. Right now I'm really like only treating types as values, like at like the purpose for that is for the compile time evaluation, right? I feel like I can like make this work though too. You also need to like prove then, right? Basically, let's say that you concatenate, you call the concatenate with like list A, which is of type list1, and you concatenate so yeah, concatenate like you would use it something like this: concatenate like 1 2 A list1, and then B is list2, right? So like you want to concatenate the list of 1 and list of 2, which will give you the list of 3 elements. And then you, let's say that you can do it the other way, so you do list 2 and list 1, right? And then you do that, right? So what you have as a result is that you don't have list 3, right? You instead have list 1 plus 2, and in this case you have list 2 plus 1. So now like you don't even know that this is 1, right? Because this is a runtime value. So you need to prove basically that A plus B and B and B plus A is the same thing if you want to these two things to be the same type, right? So which means that we need theorem provers also embedded in the language for proper dependent types, right? Because yeah, basically over here you have an expression as type, right? As far as I understand, which that's what's needed for full dependent types. because you don't really you not always can calculate this because this is a runtime variable, right? So yeah, it's like it's more like this is A, this is B, and this is like I don't know, B and A, right? You call this. This is some runtime value. So in this case, we get A plus B, which we don't know the values of A and B. And in this case, we get B plus A. So we need to prove that they are the same things. Does Const have CFFI to interact with the system? Not yet, because I only have the interpreter. I'm focusing on the interpreter, then I will focus on JavaScript probably in the browser, and then I will focus the native stuff. Actually, I don't know. Like, I want to rewrite the language itself kind of relatively soon. But I think I will still do it through the JavaScript route because it's easier. And LC proves that substitution can do computation, which is why having a type system with substitution is enough to do dependent types. LC is lambda calculus. So yeah, basically you're saying that I have like I think like I have enough functionality to implement dependent types basically, right? But I need to look a little more into it. To like, yeah. So it's an interpreter, and you build whatever system supports it needs into that. No. The interpreter is important right now because my language has compile time evaluation similar to Zig, right? So Zig also is targeting an interpreter, which is built into Zig, right? But like the problem is that you cannot target anything else until you have the interpreter, because interpreter is what powers the compilation. So I'm targeting the interpreter first, right? So right now I'm using the same like stuff at runtime, which I use at compile time. But later I will be like actually properly compiling and not interpreting the thing as just another target. But while compiling to a different target, there's still going to be the interpreter that's running at compile time. Because compiler is interpreter. That makes sense? Right. I still did like almost zero progress on my thing. Print pattern options. Option print pattern. All right, there we go. And then this over here says options. So we just print pattern shape options, FMT shape, and then we print data. Options FMT data. Easy print pattern. And this was literally just copy pasted code here. Nice. I remove this copy paste now. Okay, and then over here print pattern with spans is going to be just instead print pattern options. Print pattern options. Pattern options. Pattern options. Wait, do I have options here? This is just when I'm printing the type. Yeah, in this case, I don't print anything. Yeah. So we just say options. Bands is false. Types is false. I'm printing a type of a generic. Yeah, that makes sense. Print pattern. Print binding. All right, let's see now. Print expression shape. Shape print. Okay. Is that being used even? Shape.print. Print type shape is. What about this? Expression shape. I mean, yeah, let's have that anyway. I suppose print expression shape. I'll have the options here though then, right? Options is with cache, impl, print, expression, shape, prints with cache. Wait. That doesn't even work. So here is an example of where carrying could lead to a bug. Wait, how does it not even lead to a bug? Oh, because with cache is having, yeah, because that has the formatter. That makes sense. So function must be a function from formatter to A2 unit. Yeah, that makes sense. Yeah, okay, never mind. Not in this case. Let print assigning expression with spans. With, let's just do print assigning expression. Options. With cache, impl, print assigning expression. Print with spans. I just say print. Print assigning expression. Print assigning expression shape. Print pattern. Okay, now we get to the interesting part, right? So we get to the interpreter of the place expressions and stuff. So previously, when I'm doing the assigning, and I'm doing the assigning of an expression. Wait, but before I can do the assigning here, I need to also do the actual types and values of references, right? Let's go back here. So I introduced the expressions that I need, but I also need a new type of a value, which is value reference of. So we are referencing a place, right? We are referencing a place. What is a place? A place is a thing which actually stores the value. Place. A place is literally a thing which has a value, and we will have it mutable, I guess. Mutable value is value. Like this. That's literally all, right? That I need to do. I mean, technically, because I want to have the not initialized things, the value might not be there yet. So it should be probably a value option. And we should know the type of a place then too, right? So it should have type, have a value that goes in something, to have a reference of a place, right? Yep, that's it. And then we also should have the type. Just copy paste this over here. And then type. We need a reference to a type, right? Reference to another type. Reference to another type. Okay, now we need to print those. Let's see. So when I print type reference to inner type, and we print reference, and then we print type inner, right? Like so. Okay, and then when I print the reference. When I print a reference, what do I print? Do I actually print the value behind the reference? I feel like I don't. I print value, which is a reference. I should just print. It's like, because that's basically a pointer, so we should only like print the address, the ID maybe, or something. Yeah, maybe I should have IDs in my places. That would make sense. Reference. Yeah, we have reference to place. ID. Print place ID, you know. So place should have an ID inside. IDT. Okay, type of value. So if I have a type of if I'm trying to get the type of a reference to a place, then this should be a reference type, and we are referring to the places type, like so. Right. When I am inferring the value shape, if I know that the type of the value is a reference to a type, then I know that this is a reference to some place. I think I actually... No. There is no way I infer that. That would be constructing a place. Yeah, no, we don't infer anything here. Unite value shape. If I have a value which is a reference A, and I have a reference B, so I do that only when A is equal to B physically. Wrapper equals AB, then have reference this. Otherwise, references don't unite with anything. Okay, and then the type unification is just if we have reference to type A and we have reference to type B, it means that these two types are the same. So we say reference to unite types AB, like so, right? And if we have reference and a non-reference type, then we fail the inference. Okay, that's easy. Substituting the bindings. Oh no. If I have a value reference to a place, do I even substitute any bindings here? I'm not sure. Let's return original value here. Do. If I substitute the types, then it should definitely be substituted. If we have a type reference to inner, then we should have type reference to substitute type state inner. Right? Okay. Now the interpreter part. Now okay, so now when I'm assigning to the assigning expression, we no longer have the binding, but instead we have the assigning to a place, right? So because now we are literally having place expressions, place, right? This means that I need to evaluate the place expression. Evaluating the place expression is just literally giving you a reference. I mean, it gives you the place, right? And so we will just assign the, instead of doing scope assign to existing, because that was a hack, we literally just put the things into that place, right? So we say that place is evaluate. We need to have evaluate place expression place state, right? And then we say, so the type of this is going to be place. And types impl cast types. Like I need to export this or something. Type place is wait, it's not here. Type place is types place. Is that what I want? Module place type t is place. Something like this. So you had to pause your thinking to go do some OCaml business, and ideal language and tooling would seek to completely avoid that. I feel like C also has L values and R values. That's what I said. I mean, wait, yeah. Does C call them still L values and R values? C L value. I guess it does, right? The identifiable location in memory. Like it's not the C++ specific thing. So yeah, I evaluate this, and then I just say that place.value is some value. That's literally it, right? I'm just assigning this value into this place, putting the value in place. That's what I'm doing. Now we don't find that. Yes, we don't do this. Okay, and we don't have expression binding either. right? But we will have the new function, which is evaluate place. Yeah, let's just call it evaluate place, maybe. Evaluate place is we have the place place expression, and we get back a place. That's literally it. So we have fun state expression into match expression shape with. Now we have a place expression binding. Otherwise, I should like with to like block for now. Let's also have this try and tracing here. So evaluating place. We say that this is my result. Right, and then I need to do that. Like so. So result in this case is not a value. This is going to be a place. I'm not printing the places, so we just say evaluated place here. Whatever result is supposed to be a place, unwind, raise while evaluating a expression. Place expression. Just say place expression at this span. All right. So when I'm evaluating the binding, which is an expression, right? Now, it means also that in my interpreter scopes, we basically have a mapping from a symbol to a place instead of having a mapping from a symbol to a value like before. So I need to change what my interpreter scope is. Interpreter scope. Can the OCaml language server work at least like once, please? Go to definition. Finish gamer, hi. Restart language server, maybe? OCaml just doesn't work. Play result has type value, but the expressions type shape. Let's just do fail with lock. It should be result though. But this is a different like thing, which should already be compiled, and like it just doesn't work. I hate OCaml. Interpreter scope. Fine. We do it using find instead of using the LSP. So we have locals, interpreter locals. We have by symbol. By symbol, we are having interpreter local, which has value and type field. But so instead of storing the value here directly, which is mutable, because basically this is already a place, right? So we instead just say that this is a place, which is of type place. That's all. Interpreter local, and then we do it twice because it's OCaml. Is place. Okay. Yeah, so assigned to existing is a thing that should not exist at all, right? We don't have assigned to existing anymore. We are just finding the places. That's all. Yes. Remove this completely. So, and when we do add locals, we have new locals. Local value. Local does not have a value. Potentially. Edit, this is scope. This is the logging. Let me comment this logging. I mean, let's do this over here. It should be like not value print then, I guess, but it should be like option print value print local place value, because the value is potentially not even there when I edit it, right? Because I am adding places and not values now. Add local, and then there's like adding a single local, by the way, which is different. Why is it different? I don't know. So I'm adding a local value. In this case, I'm creating a new place. I think this should be removed over here at the top. To do would be removed, maybe, potentially. So yeah, we have place, which is a new place for the thing to live, right? Yes. Let's do place, new place, in it, with value. Let's just do it in line here for now. Value is value, type is value is type of value, right? And then ID is ID generate, like this. Value is some value, right? So for now, we just always initialize, we always have only initialized variables. Yo, DM Malroy, hello. Dylan Reid, welcome guys. DM Malroy, hi. Guys, how are you doing? Did you solve the advent of code or something? Or are you not here because of the advent of code? I already solved, so like I'm trying to do here, welcome everyone, I'm trying to solve the advent of code in my own language. I already solved the day 4, it was really easy. And now I'm trying to improve the language. Just was doing the stuff, but you love OCaml, alright. Yeah. I have a love-hate relationship with OCaml, like, you know... I cannot really say that I love OCaml. I use it here, yes, but I don't know if I actually love it. I'm more of a Rust enjoyer, but I have problems with compilation times in Rust, which is why I'm using OCaml. Yeah, that's it. But fine, I will try to not like complain about OCaml too much, since I was rated by OCaml lovers. Thank you for the raid again. But yeah, so what's happening right now? I am introducing place expressions and references to the language so that I can have mutability, right? So which is going to be more similar to Rust than to OCaml, when you can create the reference, which is like a special type, but yeah, like literally more like Rust, you know. Yeah, that's what we're doing. So like place expressions, if someone is not familiar with Rust, is similar to L values in C++. So when you see X in code, it does not actually mean that we want to know the value of X, right? This is just a place where X lives, and sometimes we want to know the value of X, and sometimes we only want to know the address of X, right? So yeah, with place expressions, we can do two things. We can either like get their reference to them, or we can actually try to extract the value out of them. Yeah, so that's what I'm doing. Local value. Yeah, so like previously I'm having an interpreter right now, right? So previously my interpreter was having a mapping from like symbols to values, and now we have a mapping from symbols to places, and places have values inside. So find opt. Yeah, so now when I'm finding something in the interpreter scope, it does not give me the value directly, it gives me the place instead. Right? And so that's what we return, the place. Okay, then when I'm substituting the bindings, when we have this thing, we have local place. We have local place, and I need to substitute the binding here, right? So I say that value is local place value option get, right? So for now we will panic if this thing is not initialized. Actually, let's do it a little bit more fail, like error resilient here, right? I'm just going to say that when I'm substituting the bindings in this thing, yeah, I guess I don't worry about the move semantics yet. But if it is some value, then we return the value, I guess, right? But if it is none, then I will say that I tried to replace, tried to use binding to place without value, which is either not initialized placed or a place which has the value moved out. But we just return the original value or something here. Actually, is that what I return? I don't even know what I return here. Let's return the original value, sure. Okay, now when we substitute the type, oh, that's the same thing. Yep. That's the same thing. Do I not have the span here? I do. Oh, I have context span. Yeah. Context span. Original value. Do you have original type? Yeah. Yes, that's what I return. All right, so now interpreter. When I'm doing pattern matching, I have I'm trying to match a value with a pattern. And actually, when I'm doing the pattern matching, what we should be doing instead of we should be doing the matching of places with patterns, because we don't always want to like move things out. But I'll worry about that later, I suppose. By symbol pattern match, right? So this over here we have a pattern binding. Wait, do I still have a pattern binding? Yeah, I do, because this introduces a new variable. So this over here is going to also create a new place for me, right? Yes, that makes sense. Pattern matching introduces the new places. ID generate value is some value, type is value, type of value, right? I mean, type of value is not even like necessary. I don't need to calculate the type of value here, right? Because we already have the type. It is pattern data type. They are supposed to be the same. So when I'm evaluating the place, I'm trying to find the binding name, which is the symbol in the current scope, which is going to give me the place. And if it's not found, because we want error resilience, we will say that this thing is not found, and we will introduce a new place, right? We will introduce a new place, basically. Do I introduce this with a value of the error? Or do I do a new place without an... Like, that's the only question that I have. But yeah, we introduce a new place where, let's say value is none, sure. ID... generate new ID, value is this, and type is going to be... How do you feel about ways to encode these cases of should be the same in the type system? What do you mean? What's the example? What are these cases? Oh, you mean like should be the same? I mean, this is the interpreter. Interpreter is ran on the type checks thing. They should be the same. So I guess I could have an assert here or something. But like the type inference should have unified these variables. Right? So I have like type stored in multiple places, but they are supposed to be unified. Well, I mean, calculating the type of a value potentially performs some calculation, maybe? Yeah, I don't know. Basically, if they are not the same, it means that I have a bug in my type checking. Which means that it's encoded in the type system, right? Or you mean encoding it in the type system of OCaml? So somehow, I don't know. I don't know. I don't think that's possible. But we can have an assert, but it's not a type system. Because how would you even do that? I have no idea. Type of a place expression. Place expression of this type. I guess we just have expression data type here too. That's what I return. So if the thing is not found, then I do that. Okay. Yeah, makes sense. Makes sense, I think. Evaluated binding to be this. Let's just do ID print. Result ID. Just some logging. Okay, and then I return result here because now that is actually a place. Nice. Evaluate place. Let's do the evaluation for all of the other types too. So we have place expressions, field, deref, and temporary. Okay, let's do place expression temporary. Expression means that I just need to evaluate the expression that is evaluating to a value. So we just say evaluate expression. And then I'm just putting this into a temporary place, literally, where value is some value. And that's all. Right? Just literally create a temporary place here. And then we have a place expression deref. So over here we have the reference. So we need to say reference is evaluate the reference. This is an expression which must then be expected to be a reference, right? So this type has reference, and reference is still a place, right? Wait, that's literally what we do, right? Expect reference, that gives me a place. That makes sense. That's all. But I need to create that. And then we have a place expression field. Object, like other things, which is right now over here. But now we don't have expression field, we have place expression field. place expression field, we evaluate the object. So to get right now, to get the place inside of an object, we still need to know the value of the object, which technically maybe is not always necessary. But sure. So we evaluate the object. It's a tuple. In this case, we return field, a value tuple field. Okay, so yeah, so here's what it means also. It means that my values, if I have a tuple, then tuple fields, they don't contain the values. Instead, we hold places inside of the tuple so that we can get references to them, right? So yeah, this is just places instead. Value tuple field. Place. Okay, so when I'm printing this, okay, so I think I also need to be able to print places. Yeah, let's do that. Place and print place. Matter place unit. Like sometimes though, I want to print a place which is just a pointer. Print place value. Maybe like this, right? Print place value and print place reference. Something like that. So tuples are pointer chasing. In the current implementation of the interpreter, yes. Yes. But that's just the interpreter. When we compile the things, it's not going to be pointer chasing. Like, yeah. Yeah. You need generics to avoid it, I guess. I already have generics. It's not because of that. Like, as just because it's an interpreter. I cannot have a reference to a variable in a camel. In order to have a reference to a value in a camel, I will need to do the pointer chasing anyway. 1 second. All right. I need to do something. So think that I'm going to end the stream here, but I might come back later to finish this stuff. Any other OCaml endures streaming currently? Eduardo, who is off stream. AFK currently. Okay. the 3 OCaml developers. Is Dylan writing OCaml on his stream? I thought he was doing like a TypeScript though with effects. He likes OCaml, but he's not using OCaml, right? Currently, at least on streams. You have his OCaml talk in your watch later. Where do we go? Any suggestions? Tour dev, Xber. Take a look at who this is. Gente is working on his link. Yeah. What is this though? Oh, this is Russian. At least like everyone in chat here is Russian. Yeah, let's go to Tagenta. They're also making something. What they are making is closer to C++, as I understand it. But they also have like some compile time evaluation. I took a look at their repository. There seems to be some cool things. They have a lot of information written already. So yeah. See you guys later. Bye.